Alrighty, folks. In this one, we are going to get into 8.7. Right, we've already covered this one time. So the time that we covered this, we covered 0 over 0 and infinity over infinity as indeterminate forms. These two forms are the only ones that allow me to do L'Hopital's. However, there are other indeterminate forms, so these 5 that I have listed, that you should know as well for the BC part of the exam. So with this, just remember that I'm not going to make you do it in BC of A over B, or whatever. Right? So really, in order to be able to use L'Hopital's, it has to be in one of these first two indeterminate forms. So 0 over 0, infinity over infinity. So technically, the way to prove this is to show that the limit as x approaches infinity of a equals, say it equals infinity. And the limit of b, right, my denominator is x approaches infinity, is infinity. Therefore, I can do L'Hopital's. Wow, that's really bad handwriting. And that allows me to say then that the limit of x approaches infinity of a over b is equal to the limit as x approaches infinity of a prime over b prime, right? So just remember, this is the derivative of the top over the derivative of the bottom. This is not the quotient rule, so make sure you're not mixing those up. So AP test, if you see this on a free response, you're more than likely not going to see it on a BC free response. AB you could, it's more likely for an AB test, but BC you're probably not going to see it. But this is the technical way to write it out. You have to show all of this. If you don't, you can't technically use L'Hopital's. But like I said, I'm not going to require that of you guys because it's going to be a lot if you see this, and you will see this on some free response. So evaluate the following. So on this one, all I'm going to be looking for is that you have implied I have 9 plus 3 is 12, so that's 0 over 0. So then I can use L'Hopital's, right? So show me an equal signs, and show me that you have L'Hopital over that equal sign. L'Hopital over the equal sign, here we go. All right, so derivative of the top over derivative of the bottom. And then if I actually plug in 3, this is 2 times 3 plus 1 is 7 over 1, which is indeed 7. You could also, yes indeed, factor out, and then no L'Hopital's is needed, right? So x plus 4, x minus 3 over x minus 3. Your x minus 3's will divide out, so this is 3 plus 4, which is 7. That is completely fine here too. So this is an option where I can use L'Hopital's, but I don't have to. And if you're going to, like I said, all that I was looking for is that you would show that it implies 0 over 0, and then you're going to use L'Hopital's. All right, moving on. So here, if I think about the form, if I plug in the numbers, e to the negative infinity is the same thing as like 1 over e to the infinity, which would be 0. So this is 0 times the square root of infinity, which is just infinity, so it's indeterminate form. But I need to get this in something over something before I can use L'Hopital's. This one's pretty straightforward because it gives me the negative exponent and I see it. So I can rewrite this as root x over e to the x. This would imply infinity over infinity, which is indeterminate form. So I can use L'Hopital's. Whoop. So 1 over 2 root x over e to the x. And if I plug in infinity now, this would imply 1 over infinity, and the 1 over infinity up top, that goes to 0. So 0 over infinity will be 0 in the end. Okie day. This one, if I plug in infinity as is, so this would be 1 plus 0, 0 to the infinite power, 1 to the infinity power, which if I go back to the very beginning, is one of my indeterminate forms. It is this one right here. I cannot say that that is just 1. It is 1 to the infinite power, and it's actually not going to come out just 1. So in this one, there's nothing that I can do to make this be 0 over 0 or infinity over infinity. If I try to rewrite my t exponent as like t plus 1 to the t over t to the t. Then with my differentiation, if I try to do L'Hopital's, that's going to have to use logarithmic differentiation, since I have a t and a t, and that's no fun. So what mathematicians did, let's see if I can pull it up quickly enough. Oh no. Oh, maybe. Yes, I still have it. Okay, so the limpet of a composite function. So just notice the big thing here is that I can't draw in here or anything, but I can use my cursor. So the limit of a function within a function, I can actually pull that without or outside, so move the limit inside the function, which means I could also do the same thing. If it were beneficial to take the function and move it inside my limit, that is still the same thing. Those are equality statements. So let's go back and see. The deal here is this t exponent. So what mathematicians did is they said, well, how could I get that t exponent out of the exponent? Well, so let's say this is equal to some number y. Well, if I take the natural log of both sides, I'm going to move y over here. Then if I take the natural log of the limit, natural log of y, right? Then the nice thing here is with that composite definition that I just showed you that we learned like week 2 of AB, I can take that natural log and I can take it of the inside part. And what that will allow me to do is take that t and move it down to the front. Right, because by, come on here, server. By exponent rules and logarithms, if I have a t exponent up there, I can take it and move it to the front. So that makes this much easier to work with, because now what I can do is this is still indeterminate form. It would be infinity times 0, because this would be 0, so ln of 1 is 0. So that's indeterminate. So I would want to rewrite this. Over 1 over t, right? Because I have taken this t to the first exponent, t to the first power, and making this t to the negative 1 in the denominator. Now this would imply 0 over 0, which is a indeterminate form. That allows me to do L'Hopital's. And let's see, so this would be the derivative of the numerator, right? ln of the thing inside. So 1 over the thing inside, so 1 over 1 plus 1 over t, times the derivative of the thing inside, so negative 1 over t squared, all divided by the derivative of 1 over t is still negative 1 over t squared. And the nice thing here is these two things divide out, right? And I'm left with 1 over 1 plus 1 over t. And if I plug in infinity to there, right, really I'm plugging in infinity there and thinking about how it behaves, that goes to 0. So this whole thing is just 1. So ln of y equals 1. Not my answer, right? Because I took the natural log of both sides, so I need to go backwards. So I can say then that y equals e to the first power, or y equals e. And I can leave my answer like that, since in the beginning I defined whatever number this comes out to be as just y. If you didn't do that and you just went straight down here, then it would be beneficial to go back to your beginning and throw in equals e right there. All right, moving on. I think we only got a couple more. Yeah, almost there. All right, so this one, same sort of idea. So let's think about how they play out. Sine of 0 as it approaches 0 from the right is 0 to the 0 power, which is an indeterminate form. So again, this is one where it's going to be beneficial, especially with that x as an exponent, to use the natural log forms. So I'm going to say this equals y. So then ln of y equals the limit as x approaches 0 from the right of x ln sine of x. That is still 0 times negative infinity, which is indeterminate form, but I want to rewrite this. Right, and this would be negative infinity, right? Let's see, sine of 0 is 0. ln as it approaches 0 from the right goes to negative infinity, and 1 over x from the right goes to positive infinity, so that's an indeterminate form. So this is ln y equals, I'm going to use L'Hopital's. So 1 over sine times the derivative of the inside all over negative 1 over x squared. And if I plug in 0 now, it should be 0 over an infinity, which I don't really like, but let's rewrite this and kind of think about these things again. And I can rewrite this. Cosine over sine is cotangent. I don't really want to do the derivative of this if I have to. And if I rewrite this, because the derivative of cotangent is negative cosecant squared, but if I move this to the denominator, move up my 1 over x squared, this can allow me to get to negative x squared over tangent of x. So let's think about negative x squared as I go to 0 goes to 0. Tangent as I go to 0 goes to 0. So this is still indeterminate form. So ln of y is limit as x approaches 0 from the positive, negative 2x over secant squared, which would be 0 over 1. So ln of y equals 0. So rewrite this as y equals e to the 0, which is 1. So all of this thing equals 1. All right, so again, the big thing about this one was just realizing that like the exponent there, and taking the natural log of both sides, moving that x down, and then knowing characteristics of your graphs as you go. Okay, last one. So let's see, if I do a straight substitution of 1, this would be 1 over 1 from the right is 0, so that's an infinity minus, is that an infinity? No, yeah. 1 over 0, so that's an infinity. So that's infinity minus infinity, which is an indeterminate form. So now I need to be able to rewrite this as a fraction somehow. Well, the only way to really do that is to get common denominators, which would be multiplying up your x minus 1 and your ln of x over that denominator. And then this will allow me to do L'Hopital's from here. All right, so derivative of 1 minus 0 minus 1 over x, derivative of natural log. And then down here I'll need to use the product rule, right? So do the derivative of the first times the second plus the first times the derivative of the second. So just realize those are two multiplied together. So I'm going to do ln of x plus x minus 1 times 1 over x, so x minus 1 over x. All right, and this is ugly. I don't like this because this has an x in the denominator, that has an x in the denominator. But if I multiply by x over x, that will allow me to just say x minus 1 over ln, maybe, ln of x plus x minus 1. Right. So now if I put in 1, let's see, this would be 0 over ln of 1 from the right is 0. So 0. 0 over 0. So I need to use L'Hopital's again. So hopefully this is the only time I need to use it again. So I have 1 over x plus 1. Right. So this is 1 over 1 plus 1, which is 1 over 2. And that's it. All right, so it's really just taking your time through these things. I know I went probably quicker than you would be comfortable with, and that's fine. I just go through these quick so I know you guys can pause and rewind and do all that good stuff. So please ask me questions in class, whatever I can help you with. The big thing with this is recognizing your indeterminate forms. If you get 0 times infinity, that's not just 0. If you get 1 to the infinity, that is not just 1. Infinity minus infinity isn't necessarily just 0. 0 to the 0 is not 1, and infinity to the 0 is not 1. Those are indeterminate forms that we need to do a little bit more work to actually be able to find something for them. Okay, hopefully this is helpful, and I will see y'all soon.